My amazing mathletes, this is section 3.4, day 2, solving rational and radical equations. Yesterday we did the rational, today we're going to do the radical. So radical equations are equations that have these square roots. Awesome. One thing that I wanted to first of all say is if you want to sometimes eliminate a whole bunch of work, if you ever get to the square root of x equals some sort of negative number, then you can stop right there. You don't have to move on any further because the positive square root of x will never equal a negative number. And this is true for even like imaginary numbers too. So as soon as you see something like this, and by the way, you don't have to worry about imaginary numbers in this section. You don't even have to often worry about negative square roots, and I'll show you that later. But for right now, just know that if you take the square root of x, if you get to the square root of x is equal to negative 3, or the square root of x is negative 6, or square root of x is negative 9, then you can stop right there and say there are no solutions. It is impossible. Okay, so some strategies, some things that you will see in no particular order. Often we'll be squaring both sides to get rid of radicals, as you will see, as you can see right here. Like, how do we get rid of that radical? The trickiest part of this equation is the radical, so square both sides. When you do, right before you square both sides, you might want to make sure that you've isolated the radical. So for example, here, at the very beginning of this, you'll see that there's two radicals next to each other. Well, if you get one of them all by itself on the same side of the equation, then that'll be a lot easier to take care of. Or for example, let me find, okay, here. Here, in this line, we've got a huge long equation, and there's one radical. So the strategy is to get everything else to the other side and get the radical all by itself, which is what you can see that I do leading up until this point, this gray dot right here. Once the radical is isolated and all by itself, then you can square both sides. That's another strategy. And then here, you are going to need to check your solutions. Algebraically, we're going to be required to eliminate extraneous solutions. Like you can see here, like at one point, I think that we've got two different answers. I think that the answer is x equals 2, or it also could be x equals 9. But when you check it out, actually, it doesn't even work. When you plug back one of the solutions into the original equation, you get 5 plus 3 is equal to negative 2. And as one of my students said, that's messed up. You shouldn't have, algebra shouldn't do that. But actually, because of the techniques we're using, you have to eliminate extraneous solutions. Because why check the solutions? Like, check this out. Here's a simplified version. Let's say you start out with just x equals negative 2. Fine. Square both sides, and you get x squared is equal to negative 2 squared, which is 4. Now, if you wanted to solve this equation for x, you would take the square root of both sides, right? And taking the square root of both sides, you get x equals positive or negative 2. Both positive and negative 2 will work in this equation right here as solutions. But what we've done by squaring both sides is that we have introduced extraneous. The positive 2 is an extraneous solution. It only ever started out as x equals negative 2. So when you square both sides, you introduce numbers that aren't necessarily the solutions to the originals, which is why we have to do the all that checking. Okay, so those are the strategies. And one more thing that you need to know is that there's an incredibly common student confusion that comes with squaring. And it all boils down to one term distributes, two terms FOIL. What do I mean by that? Well, check this out. We've got 3x, the quantity 3x squared. And if you were going to simplify this, you get 2 distributes to the 3, which is 9. And x squared just turns into 9x squared. Fine. However, if you take the same thing and just add insert an addition, it's not 3 times x, but 3 plus x squared. All of a sudden, it's 3 plus x times 3 plus x. In fact, in this section, I'm going to use this formula a lot, a squared plus 2ab plus b squared, so let's make sure we remember how to use that. But here, if there are two terms inside the parentheses, then they FOIL. There's one term inside these parentheses, the one term is 3x. But there are two terms here, 3 plus x. So then we have to FOIL it. First, outside, inside, last. Let me continue to show you what I mean. Here, if you have one term inside, then when you square the whole thing, you can just distribute the 2 to the negative 5, negative 25. Distribute the 2 to the x squared. X squared times x squared is x to the 4th. Distribute the 2 to the y to the 3rd. Remember, when you take a power raised to a power, you can multiply the exponents. 3 times 2 is 6. However, if you insert a little addition, if you say it's not multiplication here but addition, then all of a sudden you get something that you need to FOIL. One term distributes, 2 terms FOIL. Big confusion, often it shows up here. One term, this is one term, the square root of 3x squared. And when you square it, you get this, 3x squared. Because the 2 and the square root cancel each other out. However, if you have 2 terms, then when you square the whole 2 terms, you have to FOIL. One term distributes, 2 terms FOIL. And you'd have to find the first term, the outside term, the inside term, the last term. Or you could use a squared plus 2ab plus b squared. Either way, you can't just distribute. Here, this is technically one term. And this is the really confusing part because students see the addition here and they're like, addition, there must be 2 terms. Well, yes, there are 2 terms inside the square root, but in terms of what we are squaring, this entire thing is all one term. The one term is the square root, and when you square this one term, the square root and the square root cancel each other out, and you're left with what's left inside the radical, 3 plus x squared. Compare that to this, well, yeah, you would definitely have to FOIL that, and that is a lot of work. But you can do it, and it's possible. Okay, so that's the common confusion. Let's get started on actually solving these. Now, check this out. If we want to get rid of the square root, it's isolated, great, square both sides. You get 4 squared is 16, and the square root of 3x plus 1 squared is 3x plus 1. This is all one giant term, so they cancel each other out. And when you solve, you get x equals 5. Now, is x equal 5? We squared the entire equation, so remember, the solution might not even work, but when you check it in the original equation, you can see that it does. All right, kiddies, it's play at home time with Desmos. What that means is when I do something on Desmos, you do it too. Make sure you can show me your saved Desmos graphs when you arrive in class tomorrow. So here what I'm going to do is I'm just going to type in my equation, and remembering that Lansing is the capital of Michigan. Because Lansing is the capital of Michigan, that's your audio check. Let's see what happens. We get this vertical line right here. Where is it? X equals 5. Next. Here, 5 plus square root of x plus 7 equals x. I'm going to isolate the radical. You can see bring the 5 over to the other side, getting that radical all by itself, and then I square both sides. Well, here there's one term. It's the square root radical term, and so this all becomes this. And here you can see there's 2 terms. One term distributes, 2 terms FOIL. And I'm going to use the formula here, letting a equal x and b equal 5. This is going to be a squared minus 2ab plus b squared. And now we've got something that we can simplify using, or solve using a quadratic technique. Bringing the x over to the other side, subtracting x from both sides, you get negative or minus 11x. Subtracting 7 from both sides, you get 18. When you factor, that's what you get, because remember, the 2 numbers that multiply up to 18 and add up to negative 11 are negative 2 and negative 9. So this becomes x minus 2 times x minus 9. Splitting it up, you get x minus 2 equals 0, or x minus 9 equals 0. So therefore, x could equal 2 or x could equal 9. Or so I think, because what I've got to do is I've got to check my answers. When you check your answers in the original equation, you find that, wait a minute, all of a sudden, plugging in 2, just like here, we think it's an answer. You plug in 2, and you get square root of 9, which is 3. 5 plus 3 is actually not equal to 2. 5 plus the negative square root of 3 is equal to 2, sure, but that's not what we're calculating. So this is an extraneous solution, and so we should not report it as an answer. 5 plus, checking 9, it does work. We get a square root of 16, which is 4. 5 plus 4 does equal 9. So the only one answer to this equation is 9. Here we've got 2 square roots, and the short version of how we do this is we repeat the whole process twice, because there are 2 different radicals. As a strategy, I'm going to isolate one of the radicals just so that the squaring process gets a little easier. So you can see this gets all by itself, and we have 2 terms over here. So when we square it, 1 term distributes, and 2 terms have to FOIL. Square root of x plus 5 squared is just x plus 5, because this is all one giant radical term. However, we've got a term here, a is 4. We've got another term here, b is going to be the square root of x minus 3. Holy moly. All right, so when we FOIL these, or when we use the a squared minus 2ab plus b squared formula, we get 16, that's 4 squared, a squared, minus 2ab plus b squared. Simplifying, 2 times 4, we get 8. And then squaring all this, remember this is one term. So this is x minus 3. Now we're going to have to isolate this radical. We have to get the radical all by itself here. So I'm going to move everything else to the other side first. I'm going to subtract x, subtract 16. I'm going to add 3 to cancel out the subtract 3. And then so here we get that these 2 x's actually even cancel out, which is great. And then we're just left with negative 8 equals negative 8 squared x minus 3. I'm going to further isolate the radical and dividing both sides by negative 8. Dividing both sides by negative 8, we get 1 equals the square root of x minus 3. Finally, it's isolated. Great. Square both sides. 1 squared is just 1. And then the square root of x minus 3 squared, because it's one term, they distribute, and you get 1 equals x minus 3. Adding 3 to both sides, you get x equals 4. Here's the big question. Is x equal 4 actually a valid solution? I don't know. I want you to find out. I want you to take x equals 4 and plug it into this original and tell me whether or not there are any solutions at all. Maybe this is an extraneous solution and maybe it isn't. But I want you to find out. Here you can use Desmos to solve to check and get square root of x plus 7 is equal to x. As you can see here, it looks like it's at 9. Let's double check. Does x equal 9? Yep, there it is. 9. I'd like you to begin assignment 3D2. Copy the problem list and do the first problem, and I'll see you in class.